Okay, geometry fans, our topic for today is Unit 1-2, Measuring Segments. And before we start, let me tell you your joke of the day. What did one tomato say to the other in a race? And the answer is, catch up. All right, so we're going to start with a review of just naming objects. So if you have this right here, that represents a point. That's point P. Now this would be a line because of the arrows, and we can call that line FG because you need 2 points to name a line. We can call it line GF. Or if you have that lowercase cursive letter, you can say that that's line M. So 2 points for a line, 3 for a plane, so you can say plane XYZ. Or this letter right here, this capital cursive letter, is plane R. You don't even need the word plane, you can just write those. Now, what we're going to talk about today that's new is a segment, a line segment. The definition of a segment is that it contains 2 end points and all the points between. So here you're looking at a line, you're looking at AB. However, if we take off the arrows, and we only pay attention to the 2 endpoints, these would be the ends, A and B, and then all these points between. Now you notice we don't put points there, but that segment, that line right there, that line segment, represents an infinite number of points you could put here. The way we name this is we use AB, but we only put a bar. We don't put the arrows, because we're not talking about a line, now we're talking about a segment. Now you can also name it BA because the order doesn't matter. AB and BA, they mean the same thing. Now we're going to talk about distance and length. So as an example, here's a number line. You have 5 points, D, C, A, B, E, and then you have the values numbered off here on the line from -5 all the way to +5. If I say DC and then I put the segment bar over it, I am referring to the segment itself. Okay, I'm referring to this right here. But if you write DC without the bar, now we're talking about the length or the measure of the segment. Another word would be distance. It's kind of subtle, but if I'm talking about the segment, I put a segment bar. If I'm talking about its length, how long it is, I write DC without the bar. So, example number 1, use the number line above to find the measure of each segment. So the first one, part A, is DC. Well, from D to C, I count 1, 2, 3 spaces. So what's the length? The length of DC is 3. Now for CD, you might be thinking, okay, if I go this way, it's negative. But remember that in math, distance is always positive. At least in this case, distance is always positive. So that length is also 3. It doesn't matter if I go left to right or right to left. In this case, the length of that segment is 3. CA, from C to A would be 1, 2. AB would also be 2 spaces. BE, from B to E is just 1 space. DA plus AE. Okay, so what that means is we'll take the length of DA, so from D to A, that's -5 to 0, that's 1, 2, 3, 4, 5 spaces, plus AE, the length of AE is 1, 2, 3, and 5 plus 3 is 8. Notice that that's equal to the length of D to E, that whole thing. That's also 8 spaces. The length of DC plus the length of CE. All right, D to C is 3. And then from C to E would be 1, 2, 3, 4, 5. 3 plus 5 is also equal to 8. DC plus CA plus AB plus BE. Well, DC is 3. And then CA is 2. AB is 2. and BE is 1. 3 plus 2 plus 2 plus 1 is also 8. Now what we're seeing here, okay, and this is really important. If I take the pieces, the parts, DC, I use different colors here. CA, AB, BE. Notice that when I put all of those together, I'm getting the whole thing from D to E. And so if I add those up, 3, 2, 2, 1, that's the same thing as just counting from D to E. 1, 2, 3, 4, 5, 6, 7, 8. So this is a really important concept in geometry. If you have a segment, and if you add up the parts, they will always be equal to the total distance or length of the whole thing. If you add up the parts, you get the whole thing. That's a really important concept. So we're actually going to write that down at the bottom here. And we have a name for this. It's called the segment addition postulate. So the first thing we'll do, we're going to put a little picture here. So if I have a segment, and I'll name that P and R, and then I'll put Q somewhere in between. Now, it's not the middle. I'm not going to assume that that's the midpoint. We don't know that. It's just somewhere in between. The definition segment addition postulate says if Q, so that's a point, if Q is between P and R, then we can say for a fact that the length of PQ plus the length of QR is equal to the length of PR. And again, what that means, let's say that the length of PQ is 5 and the length of QR is 8. If I add up the parts, 5 plus 8, then I get the whole thing, which is going to be 13. So if you add the parts, and I'll put a plus right there, add up those parts, what you get is the whole thing. That's a very important concept. We're going to use it throughout the whole course. And it's called segment addition postulate. What are we doing? Well, we're adding segments. So the concept again, if you add the parts, you get the whole segment. Add the parts, get the whole segment. Okay, so let's flip it on the back here and we'll do some examples. So that's the end of part 1. Go ahead and pause it and go to part 2.